Welcome to yet another experiment. Today we look at reflection through a plane mirror. But what is a plane mirror? Well, let's find out. Now the objective of this experiment, as with most of the experiments that we have posted so far on this channel, is to allow students to perform these experiments at home. Experiments that are vital to their learning, especially in a time today where they are engaged in online learning, or virtual learning as we call it, are not just learning theory. That's not science. Science is practical. Science is real, and it's all around us. So what can we use? Really have absolutely no access to a plain pocket mirror, and you have in fact however a circular mirror. Well, as a suggestion made by a good friend of mine and colleague, Mr. Francis Chin, is to elevate your page. Now what does that mean? If this is your page, I'll use my props here, and this is a circular mirror, what you try to do is you elevate your page such that your circular mirror forms a plain straight surface. Now, this is absolutely a last resort and should only be used when you have no choice. The actual experiment, as mentioned by many textbooks, John Everson's CXC Physics is one of them, actually shows the use of a plain pocket. As with any experiment, you need to have precautions. Number one, make sure your pins are straight. Now I use at least 6 pins here in this experiment. If you do have some bent pins here and there, what you can do is use it to clamp your page down. Now a few students of mine also use styrofoam as their surface. Precaution number 2, please use a protractor to measure your angle. It's not art, you're not going to freehand it. Precaution number 3, make sure that your surface is flat and steady. Any shake or movement is going to cause an error of the eye, called the parallax error. So, there you have it. Let's begin. Let's gather our apparatus, and please follow me through. Firstly, draw a line along the long side of your page, more than halfway up the page, closest to the edge as possible. This represents the mirror line, the back of which can be shaded so that the back of your mirror is faced that direction. Using a protractor and around the midpoint of that line, measure 90 degrees. This represents a normal, which is an imaginary line drawn at 90 degrees or perpendicular to the boundary or mirror line in this case. You can label your normal, capital N, upon which or from which all angles will be measured, and the point of intersection between the normal and your mirror line, you can label it as O. All rays of light must stem from this point. Use 2 pins to clamp 2 diagonal edges of your paper onto your flat surface. This would prevent your paper from continuously moving when trying to record any values. Using your protractor, and from the left side of the normal, measure 10 degrees. At this value, use your long ruler and draw a line from point O that represents this 10-degree angle from the normal. This line represents the incident ray, our first incident ray. The angle between this ray and the normal is called the angle of incidence. On this incident ray, 2 pins must be positioned as far apart as they can be.
Place your mirror on the mirror line where point O, and hence the normal, falls at the center of the mirror. At eye level and looking through the mirror, ensure that the pins can be clearly seen. If you look closely, the pencil indicates where both pins can be seen through the plane mirror. When you can see both pins in the mirror, slowly move across the normal and towards the right side of that normal, keeping your eyes on the pins through that mirror. Where both pins appear to line up, place a third pin in front of this image on your paper so that it appears as if you are looking at a single pin. It's okay if the pin is placed initially in the wrong place. Just remove it so that it can be repositioned in order to block both pins while continuously looking through the mirror. An important point to note is that you are allowed to be off in terms of your angles by plus or minus 1 degree, since the error in reading a protractor is plus or minus 1 degree. Repeat the same procedure using a fourth pin so that while looking through the mirror, it appears as if you are looking at one pin, not 4. These pins are also called sighting pins, and it helps to demonstrate what the angle of reflection and the reflected ray will look like. This is what your 4 pins should look like on paper. Remove the 2 pins and connect the 2 holes that you would have placed. This would represent the reflected ray on the right hand side of the normal. By removing all pins, this is what your angle of incidence and your angle of reflection should look like. So on the left you can see your incident ray, on the right of that normal is your reflected ray. Between each ray and the normal represents the angle given, which would be on the left the angle of incidence, on the right the angle of reflection. By repeating the procedure listed above for angles up to 70 degrees, the following results are obtained.
Like and subscribe. If you have any questions, feel free to ask. Join us again for more experiments as we learn about physics and make it fun.